Okay, so the first lesson was dealing with the metric system. The second lesson was dealing with the imperial system. Today we're going to deal with both. We're going to learn how to convert from one system to the next system. Okay? The biggest thing is, while looking at it, is you have the ratios given to you. You'll have the ratios given to you on the test as well. Or you should, because you'll put it in your cheat sheet. But you'll have those ratios. So the biggest thing is, can you set this up? And this is why at the start of the metric system, I did that all that time of doing the stacking method, because this is what it's meant for, is this part right here. So for example, let's take a look at a question. It says, determine the perimeter of the rectangle. So the rectangle is 2.5 feet by 1.7 meters. Okay? So we can't add 1.7 meters with 2.5 feet. So we're going to do a conversion. Let's convert our meters and try and get feet out of it. Okay? So 1.7 meters. Now looking at your conversion sheet on page 9, all right? The best one that we can do is, we can do one of two things. We can go meters to feet or meters to yards. But meters to feet makes more sense. So what is the ratio? So again, I stack it. I want to get rid of meters. I want to get feet, right? What's the ratio of feet to meters? How many feet are in 1 meter?
1 by 3.281.
Right, 3.281 feet in 1 meter. Now all I have to do is multiply 1.7 by 3.281. Okay, so somebody punch that into the calculator, please.
5.5 feet.
0.5,
777.
7 repeat.
Well, not repeat, just 3.
Just 3 of them? Okay, well let's try, because we're going to use it again, we'll use as many as we can. So it's 7, 7, 7, right? Feet, we'll just leave it as that for now. Okay, so now I'm going to use that 5.5777 feet, and I'm going to find the perimeter. How do I find the perimeter of a rectangle? Add all the sides up, right? So I have 2.5 feet plus 2.5 feet plus 5.5777 feet, and add another 5.5777 feet. And that equals to
16.1554.
16.1554. Very good, thank you. There's your perimeter. Okay, not that difficult. The only thing that we need to do is we need to be able to convert using the ratios that are given to you. All right, I'm not asking you to memorize the ratios, I'm just asking you to be able to use the ratios to do that.
On our test, will we have like this?
That's what I was just saying. We're going to, we'll do one of two things. Either I'll photocopy that and put it on the test, or you'll have it on your form sheet, your cheat sheet.
So put it on.
Okay. Yeah, we'll see. We'll talk.
You'll tell us.
Yeah. Okay, let's take a look at the word problem on page 10. The land speed record is the fastest speed achieved on land by any wheeled vehicle. A turbofan-powered car holds the current record. The car reached a speed of 766.609 miles per hour for 1 mile, which broke the sound barrier. Express the statement about the car's speed in kilometers per hour. All right, so this is why I taught you to do all those conversions before. Now we have to change miles per hour to kilometers per hour. So the speed is 766.609 miles per hour. So what do I have to convert then?
The miles to kilometers.
Miles to kilometers. Okay, so I want kilometers up here, and I want miles down here. Okay, and what's the ratio of kilometers to miles, or miles to kilometers?
609.
Okay, so there is 1.609 kilometers in 1 mile. Do we agree? Okay, great. So multiply 1.609 by 766.609.
1,233.
1,233.
Decimal 473881.
Okay, 47, that's good, thank you. Kilometers per hour. Okay. Do we know what the sound barrier is? Speed-wise? Anyway? Have any of you watched that video of that, I think he's a Colombian guy that jumped out of the Red Bull capsule? He hit the sound barrier. Nobody knows what it is? It's 1,000 kilometers per hour. That's what they consider Mach 1. Okay, that's how fast you have to go. And he went past 1,000 kilometers an hour in his free fall. Anybody see that? Nobody saw that guy that jumped out of the Red Bull?
One of the.
Oh, actually.
Yeah, YouTube it. YouTube it. It's pretty impressive. The records that he broke. He broke a record. He was the fastest free fall, the longest amount of time of a free fall. I think he free fell for over 5 minutes. And then, what was the other? Well, the height he jumped at. He was miles above the Earth's atmosphere.
That'd be a pretty special suit he was wearing.
Yeah, he was wearing. It was designed by NASA. It was really quite interesting.
Goes to space.
Yeah. Yeah, exactly. Okay, so there's that, and then the second part of this said, at 15 degrees Celsius, the speed of sound is 1,016 feet per second. The speed is given a measurement called Mach 1. How many miles per hour above Mach 1 was the car's top speed? All right, so now we got some serious work to do. It's 116 point, no, 1,016, right? 1,016. 116. There we go. Look what it was. 1 second. All right. Okay. First one we'll change. Let's change seconds to hours. Okay? So because I want to get rid of seconds and seconds is on the bottom, I'm putting the seconds on the top here. And I want hours down here. Okay, what's the ratio of seconds to hours? 60 to 1. 3,600 seconds in 1 hour. Right? 60 seconds, 60 minutes, 3,600. Okay? So that gets rid of my seconds. Now I need to change feet to miles. Right? Because it asked for miles per hour, did it not? Okay, so let's look at the miles per hour. So miles goes up here. 1 mile has how many feet in it?
1,760.
Is that okay? Yes, sir.
I believe, oh, no. 1 mile is like 1,760 yards.
Yards, that's right.
Yeah,
I agree with you.
5280.
You're right. 5,280 feet. Okay, and that again is on page 5, right? Okay, so now, how does this look when I punch that into my calculator? What am I multiplying?
1,116 times 3,600 divided by 5,280.
Excellent. Okay, 1,116 times 3,600 divided by 5,280. Punch that into your calculators. Should have your calculators. Anytime we do board work, make sure your calculators are out. At least then I know you're doing something. Go ahead.
760.909. Just repeating. Just repeating.
90 both
Sorry?
90
90 are both repeating.
Okay. So just leave it as 91. And that is miles per hour, right? Okay. So how much faster did he go approximately? How much faster than Mach 1 did he go?
233.47 kilometers per hour faster.
Think so? How fast did he go? How fast did that car go?
Wasn't it 716?
766.609. Mach 1 is 760.91. How much faster did he go than Mach 1? Just under 6 miles an hour, right? So that's how fast he went. Okay? So then they asked you to change this as well. Feet per second times 3,600 seconds over 1 hour times, what do I need to change feet to? Kilometers. Okay, is there a ratio in there of kilometers to feet?
Uh, 3,280.84.
There you go. Oh, 3,280.84. Okay, so let's change that again. So I said it should be around 1,000 kilometers an hour, I'm guessing. Might be a little higher than that now. 1,116 times 3,600 divided by 3,280, what do we get?
1,224.56.
224?
Yeah.
0.56. So it was a little actually higher than 1,000 kilometers an hour. That's Mach 1. The speed of sound. Okay? Alright, so how much faster in kilometers per hour do you go? Subtract those two, you'd have about 9 kilometers per hour. Alright? Okay, so that's basically it. That's all of your chapter 1. Okay? So what I want to do, or what I will do right now, is I'll answer any questions that you had from 1.1 or 1.2. Most of you are done 1.1 already. So is there any questions from 1.2 that you'd like to look at today? Page? Page 7, question 5. Okay. Snow gauge is a funnel-shaped device meant to measure snowfall. The device collects falling snow, which is melted and measured. The amount of snowfall in inches is determined by measuring the depth of the water in inches and multiplying that value by 10. A snow gauge gathered snow over a period of 12 hours. The melted snow measured 1.5 inches. What was the average snowfall per hour? Okay, well, let's start with this then. So we had 1.5 inches of water, right? So let's calculate what that is in snowfall. How do I do that?
Times it by 10.
Times it by 10, right? So this is 3/2 inches times 10, which is equal to 15 inches of snow. And how long was it? 12 hours. Okay? 15 divided by 12. 1.25 inches per hour. Okay?
7.
Just a sec. We'll just think you can do the next one. B. Okay. Go ahead, Zach.
Number 7.
7. Same page.
Yep.
Two snowleaders leave the same place at the same time heading for the same destination, but take different routes. Josephine follows a trail indicated by dashed lines at a speed of 60 miles an hour. Marcus follows the trail indicated by a solid line at a speed of 45 miles an hour. Who arrives first? Show your calculations. Okay, so what you're going to do, okay, so how do I find, let's just, a little bit of physics right now, okay? Well, I like to start like this because I think it makes more sense. speed or velocity, I'm going to say it's velocity, is distance over time. Everybody agree? Okay, so if that's the case, then what is the time? How do I calculate what the time is? Time is equal to? How do I arrange that so I get time by itself?
D times V.
D times V? Okay, let me show you something that we did last week. Do we ever remember this from last week? I'm going to change this question, just sorry, 1 second. Let's do it like this. So we remember that, right? Everybody's okay? How did I solve for H?
We just switched them.
I switched them? So I just switched the sign 30 with the H. Right? Switch those two. It's a math thing, math trick, right? And I got that. Okay, that was right. Okay, equals 16 because the sine of 30 is a half. Everybody agrees with me? That's what we did last week?
Yeah.
Yeah? How would I get t by itself here? What is it going to equal? If I do this exact same thing I just did, what should t equal?
D divided by.
Just like that, right? Agree? Okay, so it's something we did last week, and we're applying here today. Fair enough? Okay, good. All right, so time. I need to then calculate the distance. Okay? And if you notice, both the speeds are in miles per hour, right? But the distances are given in yards. So let's find Josephine first. So she went 32,500 yards and then another 78,000 yards. So how far did she go? How far did she travel?
110,500.
110,500 yards, right? Let's change that over to miles. Okay? Miles, yards. Okay, what's the ratio of miles to yards? What is it? 1760?
Yeah. Sorry.
That equals to, how many miles did she travel? $110,500 divided by 1760.
62.784.
Awesome, girls. 62.784 miles.
Okay.
Okay, so that's how far she traveled, right? How fast was she moving when she traveled that far?
60 miles per hour.
60 miles per hour. So then if I take the time and I take that 62.784 miles and I divide it by 60 miles per hour, I'm going to get my miles canceled and it's going to leave me with hours. So take 62.784 and divide it by 60 miles.
1.7.
0.46.
46.
Thank you. 0.46 hours. Awesome. So, excellent work. That's how long it took her to get there, right? How do I find out how long it took him to get there? Do I know how far he traveled?
No.
Yeah, I do. No? No?
Well, you can find it out
How?
by Pythagoras theorem.
Very good. Let's keep this on 2 pages so we can see it because it's the same question. So I had, what was the 32,500 here, right? Over to here. Nice. 78,000 right here. Okay. We're going to use Pythagoras' theorem. And calculate his distance. What do we got? Square root of 32,500 squared plus 78,000 squared equals.
The square root of it is 8,400. 84,500.
84,500?
Yeah.
No decimal?
No.
No.
Beauty. Okay, so that's what I have right there. Right? So now 84,500 yards. Let's convert that to miles. We know that the ratio is 1 to 1,760 yards. How many miles is that? So I take 84,500 divided by 1,760.
48 miles.
48 miles, right on the nose.
0.011.
Okay, because we do have to use that number again, right? So what do you say is 0.011?
Yep.
Thanks. Miles? Okay. Time for him then is 48 miles, 0.011, divided by his speed, which is 45 miles per hour. How long did it take him? 0.066 hours. Yeah? What was the problem with it that you had trouble with? Right up here?
Yep.
Okay. I suspected as much. Alright.